Hello, every student who's doing grade 12. Here with you, we are with Zazi from Entertainment, reminding you that if it's the first time you view our YouTube channel, please make sure that you subscribe to our channel as well as comment if you have any question or any queries. We will reply to your comment. Okay, today's session will be based on calculus. We are working with the rate of change. Okay, here we have question 9. Okay, here we are told that a closed rectangular box has to be constructed as follow. Okay, we have dimension of which is a length, width, and height, and we are told that the length of the base had to be 3 times its width. So analyzing this information, so this thing implies that L of which is a length, let me write it like this. Okay, here L of which is the length is equal to 3 times the width. So meaning when we reach to the scenario where we see L, we can substitute 3W instead of L, of which is the length. Okay, here we are told also the volume to be 5 cubic meter. Yeah. Okay. Here we are told that the material for the top and the bottom part cost 15 rand per square meter. Here it's 15 rand per square meter. Bear in mind that we are talking about a bottom part as well as a top part. So it's a top and a bottom. It will cost us 15 rand per square meter. And the material for the sides cost 6 rand per square meter. Okay, bear in mind that you are working with a closed rectangular box. So a closed rectangular box consists of how many sides? It's a front view, back view, side view, bottom view, as well as a top view. Both the top and the bottom view cost 15 rand per square meter. But the one that are for side, that means it's a side view as well as front and it's a front and a backward part. So they are all covered on these sides, of which one cost what? 6 rand, yeah, 6 rand per square meter. Okay. Here is the question that we are faced with today. Okay. Bear in mind here that the volume it is 5 meter cube. What is the volume of a rectangular box? A volume for a rectangular box is denoted by the length times width times height. So it's length times width times height. So this is the volume for a rectangular box. Okay. So meaning this thing, so what we know at the moment, we know that L times W times H is equal to what? Is equal to 5. This is the information that we goes with directly to the question that is being given to us. Okay, here we are required to show that the cost to construct the box can be calculated. Okay, we are told that we have to show that the cost to construct the box can be calculated by this one. So we want to, in fact, we are required to prove that the cost should be calculated by this one. Okay. What is it that we are going to use? Okay, we know that here we are working with the surface area. Okay, the surface area. On the surface area, you know that we know that a base part, or the bottom part. There's a bottom and the top part. Okay, the base part consists of length times width. So if the box is closed, that means we'll end up having 2 length times width plus, okay, if you can look carefully, this is how the box should look like. Okay, the box is constructed like this. Let me check whether but this one, guys, won't be as nice as it should be. Okay, this is a rectangular box. Ours not drawn to scale. Okay, this is a rectangular box of ours. So we have top part and the bottom part. So we know that this part is a length, this one's a width, this one is a height. So meaning this part, of which is the bottom part and the top part, they are consist of length times width. So it's a 2 length times width because it's the surface area for the bottom and the top part. And here, if you can look carefully, here you have a width and height. Width and height, so it's a side view. So you end up having 2 width times height plus go to the front view and the behind view, front view and the back view. So here we know that, okay, this one is a height, so it's a length times height, and even on the back view also it's a length times height. So you end up having 2 length times height. So this is the surface area that we have. And I told you that the information that is given to us here, it tells us that, okay, the length of the base has to be 3 times its width, of which is length can be written as 3 times width. Meaning, we can go back here, where you see length, you replace it with what? With 3W. So here you have 2, instead of L, you put what? It's 3W times W plus, you bring this as it is, WH plus, instead of L, we replace it with what? With 3W. So it is 2 times 3W times H. Okay? So 2 times 3W, you get 6W. Okay, let's start from here. If you get rid of this bracket, 3W times W end up with W squared. So you have 2 times 3W squared, yes, plus 2WH. Here, if you multiply the 2, okay, bring back this 2. If you say 3W times H, you come up with 3WH. Okay, now you want to eliminate the bracket. So 3 times 2 give us 6W squared. And here you have plus 2WH plus, so 2 times 3 becomes 6. It's 6WH. So you check here, you do have like terms, this one and this one. So as a result, you have 6W squared plus 2 times 2 plus 6 becomes 8WH. Okay, this one is a surface area, but it is not the coast. All right, go back here. Go back here. We said that this one is same as length times width, because we agree that when you see length, you can replace length by 3W. Okay, so going back to the information given to us, we are told that the material for the top and the bottom parts cost 15 rand per square meter. Now we no longer work with a surface area, but we are now moving to the cost. So here it's a cost. So here, this one, it's a top and the bottom part, of which is 6W squared. So meaning this part costs 15 rand. This part is the one that costs 15 rand, meaning you'll be having 15 multiplied by 6W squared plus this part, of which is a side part, it's a side view. This one is the part that costs what? 6 rand. So you have 6 rand multiplying this side view. As the result, so here, if you say 15 times 6, you get 90 W squared plus, if you say 6 times 8, you get 48 WH, of which is the cost. So we started with calculating the surface area of a rectangular box, and then from there we went to this side of calculating the cost. Okay, one more thing that is important that we have to pay attention on here, the fact that they did mention that the rectangular box is closed, that's why we have 2L times W. But if the rectangular box was open, it was going to consider only the bottom part, of which is L times W, not 2L times W, but not 2L times W, but it was going to be L times W because we were going to be working with only the bottom part because the box was not going to be closed. But the fact that we are told that the box is closed, that's why we consider both sides, a bottom part as well as a top part. Okay, so by default, yeah, we did manage to prove that to construct this box, the cost can be calculated as 90 W squared plus 48 WH, of which is a weight times height. Okay, moving forward. Here we are required to determine the width of the box such that the cost to build the box is a minimum. All right, let us underline this part. Okay, here it's a minimum. So suppose you are given this construct, you are being given this contract. You are a construction manager. You want to spend as little as possible as you can to avoid wasting much money. You want to save on your site. So the question is, you have to determine the weight of the box such that the cost to build the box is a minimum. So this is what you need. It is the width of the box. So you want to find the price that's a width of the box, the smallest price of the width of the box that can make you save money and complete your work. All right. Let's check what is it that can we do here to save money. All right. First thing first, we know the volume of the rectangular box. The volume of a rectangular box is the length times width times height. Okay? And we know that the volume is 5. So it's 5, it's a length times width times height. Okay. One thing that we know also is that we can write L as 3W, meaning we can still continue here because normally this is what we should work with. It's this one. So we want to find this one that will minimize the cost. But the problem is that when we differentiate this one, it will make things much complicated for us because we still have this H. So we have to eliminate this H. How do we eliminate the height such that we are left with the width only on this cost? By going back to the information that was given to us and check whether is there a way that we can manipulate H and write H in terms of W. So this is what we are trying to do at the moment. So here you see the fact that you know that your length is 3 times your width, meaning you can replace your length by 3W. So meaning you have 3W times W times H. So as the result, you have 5 is equal to, so when you multiply 3w by w, you end up with 3w squared h. Ne? And you want to make your h, of which is the height, the subject of the formula. So if you divide both sides by 3w squared, divide both sides by 3w squared, meaning you can write your height to be equal to 5 over 3w squared. Now we are almost there. Okay, look carefully. Go back to the cost. The cost is, okay, our cost is written to be 90 w squared plus 48 wh. Now you can let your h to be equal to 5 over 3w squared. Okay, meaning here we'll end up with 90 w squared plus 48 w, meaning where I see h, I can replace it with what? With 5 over 3w squared. Okay, I think we are now almost there. We are almost there. We are almost there because we did manage to eliminate this h. We are now left with a w as the only unknown variable in this equation of ours. Okay, going back here, you have 90 w squared plus 48, okay, w over 3 w squared. So this w and this w will cancel. You are now left with what? With 5 over 3w. Yes. Okay. Okay, moving forward. If you say this one times this one, okay, it's 48 times, okay, yeah, it's 48 times 5. Let me go and take my calculator, make sure that everything is visible, you can see. Okay, so here we have 48, you divide, okay, let me not divide first, let me start by multiplying it with 5. 48 times 5, wow, it's 240. Okay, so here we have 90w squared plus 240 all over 3w. Okay, again, let us calculate. We divide 240 by what? By 3. You get what? 80. Okay, so now we are left with, it's 90 w squared plus 80 over w. Okay, we are still working with the cost. We have not yet minimized, or we have not yet differentiated our function, because this one is now the function of which is the function that we can use to calculate the cost. Okay, that's a cost. Okay, so from here, you know that this one of which is 8 over w can also be written as, okay, let's just continue with the cost. It's a 90w squared plus 8. You can rewrite this 1 over w as w to the power of minus 1. So you now differentiate this one so that you minimize the cost. So this is the cost. Okay, so you are differentiating the cost. So it's a cost prime. So here you have 90 times 2, which is, okay, it's 90 times 2. We have a W, which is a width, that's 2 minus 1. That is the rule of differentiation. And also here, if you say plus, we have 80 times, okay, put it minus 1 into bracket, and you end up with W to the power of minus 1 minus 1. So as the result, you have this one, 90 times 2 becomes 180. Okay, W plus here, if you say 80 times minus 1, meaning it becomes minus 80. Yeah, it becomes minus 1, minus 8 is minus 80, but it's W to the power of minus 2. Okay, we are almost there. Okay, it's 180 W minus 80 over W squared. Okay, so this, okay, you know that a differentiation at a minimum or at the maximum of just a turning point is equated to 0. It's 0 here, it's 0 here. So you left it to 180 W. If we can make this one, okay, let me eliminate this step. Okay, let me not. Okay, so here you want to find LCD. LCD is W squared. So you have 0 equal to, if you can make LCD W squared, or if you can take this one to the other side, but making an LCD is fine also. So you have W squared as an LCD over. So here, over this one becomes W times this one becomes 180 W cube, and this one W over W gives you 1, and 1 times minus 80 becomes minus 80. So as the result, if you can multiply by y squared both sides, you're left with 0 equal to 180 W cube minus 80. You take 80 to your left hand side, you have 80 being equal to 180 W cube. Divide both sides by 180. Divide both sides by 180. Okay. So you know that on your right hand side, you can even write it one way or another, but let me write it like this: W cube. So when you say 80 divided by 180, what do you get? Just use our calculator. 80 divided by 180 divided by 180. This becomes 2 over 4. Okay, it's 2 over 4. No, it's 4 over 9. Sorry, not 2 over 4, but it's 4 over 9. So you now have 4 over 9. Okay, we are almost there now. I want to solve for W. So how do we solve for W? You can rationalize. It's fine. It's either you just say 3 W to 3, okay, which is equal to, so it's 4 over 9. So it's a cube root of this one. Yeah. So this one and this one will be eliminated. You end up with W being equal to cube root of 4 over 9. So from there, you take your calculator, you calculate that. Okay, you want to find the cube root of, okay, it's a cube root of 4 over 9. Of which is 0.763, blah, blah, blah. But since we want to find the cost, that means this thing should be in a rands. So W is equal to, it should be 0.76 cent. So it should be 76 cent. Yeah, so this is the width. That okay, so this is our width. That will minimize the cost of the box. I hope this video was helpful to everyone who was watching here. Please, if you feel like you did not understand, write on the comment section. I will reply to your comment. Thank you. I'm looking forward to meet you in my upcoming videos. Thank you.